the next thing that we really need to get our heads around is this idea of a matrix multiplication. So you've just seen, in the previous hour, you've just seen when I drew that network, a use of matrices. Okay? Another place where matrices are really useful is applying them to transformations. Okay? So for example, if you're doing graphics processing or something like that, okay, matrices are a really, really useful thing to be able to describe those transformations from a computation for a computer to do. Okay? So have a look at the screen. What I have got here is two vectors. Okay? Now, does anybody recognize these two vectors? So I've got a blue vector and I've got a red vector. Does anybody recognize those two vectors?
Yes.
Okay, what are they?
One says 1 to x and 0 to y.
Okay, so what is the vector for the blue vector? So how would I write that as a column?
1 to 0.
Okay, 1, 0. And what would I write the red vector as? Bless you. 0, 1. Okay. Now, does anybody recognise? We did this when we're doing vectors. Okay. Does anybody recognise what those vectors are? We gave them a special name. They're really useful. Unit vector. So the blue one would be called. What letter do we give that? Bless you.
Thank you.
I. It was I, wasn't it? Yeah. You remember I? Yeah. And what was the red one?
I will. Sorry.
What was the red one?
J.
Oh. You got a name for that one as well? Okay.
I don't want to.
So I was 1, 0 and J was 0, 1. Okay. Now we give these a special name. We call them basis vectors. Okay, basis vectors. Okay, because if you think about it, we can get anywhere on this two-dimensional plane just by thinking in terms of I and J. Just in thinking in terms of I and J. Okay. So I want to build a matrix from these two vectors. And the way which I build it is very, very easy. Okay? So I set up my matrix and I store my vectors in the columns. So I would come first. So I'd go I is 1, 0. That's my I. Okay? And J would come second. So that would be 0, 1. So there's my J. Does that make sense to everybody, what I've done? Okay? Does anybody actually recognize that matrix there? Anybody that's done matrices before, does anybody know what name we give to that vector? So that matrix.
What was it? Me too. Yeah.
It's called the identity matrix. It's called the identity matrix. Okay? Which we give the name I. Okay? Sometimes you might see it written as I2 because it's in 2 dimensions. If you add an extra one, it would be I3, etc., etc., etc.
There was other type of matrix there.
Yes, there are other types of matrices.
No, I mean like it goes like this,
Diagonal matrix?
Yeah.
Yeah, and you've got transpose matrices and all stuff like that. We're not going to worry about all the different important types of matrices in this course, okay? This is the most important one which I want to get your head around, okay? So identity matrix is just simply what happens if you take the two basis vectors and fit them into my 2 by 2 matrix like so. So you happy? First column is I, second column is J, okay? Does anybody want to hazard a guess? Why do we call it the identity matrix? Absolutely true. So if you square it or if you do something like that to it, it will give you the same. Can I give you another matrix alongside to multiply? So let me give you this matrix. Let's give you 1, 2, 1, 1, 2, 1, and 2, 2. Can I give you 2 minutes to multiply those two matrices together for me? Okay, so what matrix did we get? I think most of us are there. We get exactly the same matrix back. Interesting. Why do we call this the identity matrix then?
Because it gives the same matrix every time you multiply.
Exactly. If you multiply the identity matrix by any matrix, providing the dimensions match up and everything, if if you multiply the identity matrix by matrix, you should always get the same matrix back. In other words, it stays completely identical. Okay? So, I'm going to try and put this into context for you. This wasn't just any old matrix that I made up. Okay? What I did was I thought about a very particular shape. I thought about this one. Okay? I thought about this one. So this here, can you see on the screen, I've drawn a shape. Okay? It's a square, and it goes P, Q, R, and S. Okay? What are the coordinates of P? Look on your screen, there's light over there as well.
1, 2.
1, 2, okay? So in other words, this thing here is P, right? What are the coordinates of Q?
2, 1.
1, 1. What are the coordinates of R?
2, 1.
2, 1. And what are the coordinates of S?
2, 2.
So what I am basically saying is that if I write myself a coordinate matrix, notice the way which we write the coordinates? We think of them as vectors. So we write them column-wise. Okay, so 1, 2, that's the coordinates of P. Okay? If you multiply a transformation matrix by a coordinate matrix, these are the new coordinates. So in other words, P should end up at 1, 2. Q, after I've transformed it, should end up at 1, 1. You may just summarize it as a dash to show transformed. Okay? These are the new coordinates of R, and these are the new coordinates of S. Okay? And you go, okay, so what have we done here? What's the point? We're just getting started. Okay? Because what if I wanted to rotate this shape 90 degrees around the origin? 90 degrees around the origin. Well, I can use matrices to do that for me. Okay? So let's go back to our basis vectors. What I want to do is I want to rotate my shape 90 degrees. Let's go anti-clockwise. So in other words, against the flow of a clock. So in other words, that direction. And I want to do it about the origin. So that's my center. That's kind of the point where I hold my page and turn it around. 0, 0. Okay? So let's think about where our basis vectors would end up. If it helps, you can kind of think of this on a kind of coordinate grid. Okay? So if I rotate I and J 90 degrees anti-clockwise around the origin, where would J end up? So I've rotated 90 degrees. What's the vector of J? What's the new vector of J? -1, 0. Are you happy with that? So it's going to be -1, 0. That's where J ends up. The new J ends up over here. Okay? Where does I end up?
0, 1.
0, 1. It gets rotated like that. Okay? So there are the new coordinates of I. So I'm going to draw this as new I equals 0, 1, and these are new J. Okay? So in other words, when I come to build my matrix, remember my I always goes in my first column. So my new I is going to be 0, 1, and my new J is going to be -1, 0. Okay? Just humour me. Can you multiply my coordinate matrix, which is 1, 1, 2, 2, 2, 1, 1, 2, and find where the new coordinates of my shape are going to end up? Do you get that? Do you get that? Mm-hmm. So in other words, if this was P, Q, R, and S, P, Q, R, and S, these are the new coordinates. This is new P, this is the new coordinates of Q, these are the new coordinates of R, and these are the new coordinates of S. Okay? New coordinates of S. But you notice how you generate those transformation matrices. You simply think, where do I and J end up after I've transformed? Yeah? So let's do, for example, a reflection in the line y equals -x. Okay, what would the transformation matrix be? So here we go. So if you transform in the line y equals -x, here's the line y equals -x, okay? You're going to do a reflection. Where does I end up? Where does I end up after you reflect it in the line y equals negative x? Good, 0, negative 1. It ends up down here. Okay? So this is new I, 0, negative 1. Where does j end up? So j was up there, gets reflected, ends up negative 1, 0. Okay? So in other words, our transformation matrix, which corresponds to a reflection of the line y equals negative x, should be what? So go columns. 0, negative 1. Negative 1, 0. So you literally just copy that across. Okay? Now, you notice that I'm just doing with this shape. Okay? So I can actually just move I and j to correspond to that reflection. See that on the screen? Yeah? But you notice that I can, oops, didn't let go. Okay? So that is if you reflect that shape, but you notice that I can move it around. I can make it any shape I like. So for example, something like that, or for example, something like that. So because I have this transformation matrix, I can take any shape I like and perform this transformation, and I know where it's going to end up. Does that make sense? Yeah, does that make sense? Good. So in which case then, could you have a go at these questions on the screen?